Okay, before I get into the triangles, right, just remind you, the stuff yesterday was, if you got two things, I can just limit this to shapes because you can technically throw circles in there even though you're not. Congruent shapes just meant that they were the same size, the same shape. Like at the basis, that's what congruent means, same size and shape. When you tested that was, you looked at all the corresponding parts, and if all the corresponding parts were congruent, then you could say the shapes were congruent to each other. The biggest difference between what we do with triangles and what we do with this stuff is with anything other than a triangle, you check all corresponding parts. You don't have to do all that with triangles. There are theorems and postulates that exist that allow you to do less work with the triangles. Like if I had a pentagon, five-sided figure, I would list out 5 pairs of angles, 5 pairs of sides. I would see if they were all congruent. That would take me a good amount of time depending on what's given to you. Yesterday with triangles, I actually had it listed out as one of the examples. With the triangles yesterday, we would have had to list out all 3 angles and all 3 sides. I had to match them up. I had to say, look, these things are equal, therefore the triangles are blah. You don't have to do that, okay? The 4 things that you're going to write on that paper, and then maybe a 5th one off to the side. These are going to act as shortcuts if you were to compare it to what we did yesterday. But if we ever run into a problem that says, are these triangles congruent, you're going to focus on one of these 4 things. Instead of doing, yesterday when I did the problem with the triangles, I had 6 pairs of things. For each one of these, you're only doing 3 pairs. So it essentially cuts down the work you do in half in terms of listing out the pairs of stuff you need. Okay? All right. The first one, and then I'll go into what each part stands for. Okay? Says side-side-side congruency postulate. Okay? Anytime you see the word side up there, that's standing for a pair of corresponding sides. When you see the word angle up there today, it's going to stand for a pair of corresponding angles. So what this is saying, what this postulate is used for, is if I had 2 triangles drawn out, ABC, if I had these 2 triangles, and let's just say we did work or the problem flat out had a congruency mark on every side, okay? This postulate allows you to go, look, I know all of these sides are matching up. They all have congruency marks on them. I know that all of the pairs of corresponding sides are congruent. So instead of us checking things with angles like we would have had to do yesterday, I could just look at them and go, if all the sides are congruent, the triangles are congruent. This postulate allows me to do it. So I would say that ABC is congruent to, get this backwards. No, I didn't. DEF because of the SSS postulate. So again, the S here, S stands for a pair of sides that are congruent. Okay? So this is basically saying when they have 3 S's, 3 sides, this is saying you've got 3 pairs of corresponding sides, which you do. I've got AB being congruent to DE. I've got BC being congruent to FE. And I've got AC being congruent to DF. This is something I wouldn't expect people to write out every single time. This is like a check you kind of do in your head. All right, and again, each S that's here and each S that we see from this point on today is going to represent a pair of sides. So like that's a pair of sides that's congruent, so that's what the S up there represents. S. So I've got 3 S's there. Okay? So anywhere from this point on, if I have an S up there, I'm talking about I found some kind of pair between them. The problems aren't always going to be that straightforward. We're going to go through common things also that you need to look for in order to pair up certain sides. Okay? Next one, SAS. So again, S stands for a pair of sides. So the way this would look is SAS is saying I've got two pairs of corresponding sides because I got two S's up there. The A stands for a pair of corresponding angles. The way this is written, the order of this, with them having the A kind of like shoved in between the two S's there, that's kind of important with this there. The way these things need to be marked, or the way you need to be able to get your information from the triangles. I'm going to mark off two sides, right? The S's stand for corresponding sides. So we'll say that's one pair and that's another pair. Okay? For me to apply this postulate and save myself work from what we did yesterday, again, yesterday was I had to list out all the stuff, now I don't have to. I need to be able to know something about the pair of angles that is kind of in between the two sides. Meaning like if I just focused on this triangle up here, ABC, this angle here, this angle C, does this angle C touch this side down here? Like does this side actually come in contact with that angle? No. What about, does this side over, or this angle here, does it come in contact with this side? No. Does this angle here come in contact with both those sides? So if I'm applying this, what this A, the reason it's put in between is you care about the angle that's in between the two sides. These two sides are going to form a specific angle. So the way I would need to see this marked is something resembling that. You should probably draw yourself a picture with each one of these. Like I would write out exactly what it says and then draw a sketch just to kind of remind you what to look for. This angle, guys, that's in between, this is called the included angle because it's included between the two sides that are congruent. So like that would be considered an included angle, and so would that one. All right, and again, you would still, with all these, you'd probably write out a congruency statement, right? This is still a congruency statement saying which things are congruent. DEF because S, oops. Okay. All right. Next one. All right. The next one is ASA. Okay. So again, like the letters A up there just mean they're standing for pair congruent angles. S stands for pair congruent sides. Just like the one over here, the order that these are written is important. Okay. The side that we actually will have marked congruent in our pictures has to be the side that is kind of in contact with both of those angles. It's adjacent to it. So since this S is shoved in between these two angles here, it's considered an included side. So if they reference that, that's what they're talking about. So again, if I just drew out some kind of sketch to go along with this, let's just say I marked those two angles. So this would be my 1A. So this pair would be 1, the first A. This pair over here would be the second A. And then again, if I was working towards this, the side I would want marked congruent is the side that is touching both of these angles. So like the only side in this triangle that's touching both is that one. Like this side over here doesn't connect to here. This side does not connect to that angle. So I would need something resembling that in order to use this thing. And all we're doing today is just, it's like a recognition kind of thing, guys. Just making sure that you can recognize which theorem should be applied. All right, we're not actually doing proofs today. Okay. The other one, this is the last of the main theorems used, is close to this one. The difference between this one here and the last one is where the S is. Okay. All right. So with this one, AAS, the angle-angle side, the side is only going to come in contact with one of the angles. But the one it comes in contact with, you've got to make sure that it's in contact with the same pair of corresponding angles. Meaning, if I got these angles marked again, okay, I wouldn't want this side down at the bottom because that would relate back to the last one. I would want either this one marked or this one marked. So if I had a congruency mark there, down on this one, I would want the one that corresponds to it, which is that one. Okay, or I could also have BC and EF, wouldn't matter. All right, so as long as I've got, there's my two angles, AA, and there's my one side. Okay. Because yeah.
Is it always going to be because and then like the letters?
Yes. If you didn't realize, guys, the things I have in parentheses there, that's going to be end up being on your reasons portion for when we do proofs, because it's an explanation. It'll never go on the other side. The other side, like your statements, would be actually saying which parts are congruent. The reason would always be like side, 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 side angle, side, that kind of stuff. Okay. All right, the last one, I'll show you it, but I would add this off to the side. The last one is HL, okay? It's called hypotenuse leg. The only kind of triangles that have hypotenuse in them are right triangles. So the reason I don't add this to the main part is because HL theorem applies simply to right triangles. Okay, and not every right triangle that we work with is going to have this one on there. So make a note if you write this down, which you would because you're going to use this sometimes, but put it off to the side. Make sure you note this is only for right triangles. Okay, but at the same time, that doesn't mean if I'm working with a picture and I see a right triangle that I default back to this. The other way is these four up there, that's the things that work all the time. Okay, they will work with any type of triangle. This one's only for right triangles. And the way you would have to see it kind of marked is you would have to have the right angle there. The hypotenuse, right? Hypotenuse is the longest side of a right triangle, so I would need a congruency mark there. And then the legs are just one of the other sides. So I would have to have the right angle. I would have to have the hypotenuse there. And I have to have one of the other sides there. And within the diagrams, I'll tell you what parts you can automatically mark congruent. Because what you guys are working towards over the next few days is you're working towards taking two triangles, and between the two triangles just figuring out what angles are congruent, what sides are congruent. And a lot of that's going to come from the way they draw it. Okay? I'll probably point out, let's say, like 2 things today. That should be enough for you. Okay? And the way I'll do these first 2, all right? And again, this would be something that you need to write at the bottom, because throughout, from now to the end of the week, guys, there's absolutely no reason for you not to have that piece of paper out to work from it. Okay? You need to get down to like being able to pull information from what you have there into the problems, because it would make life much easier for you. But the way I'm going to write these out is right here. I'm going to write out like what would go in your reasoning portion of your proof. Like the first one, I'm going to write as vertical angles are congruent. Okay, so this will act as like a reason when you're writing proofs out. Now, if I put this for a reason, that means that as a statement, I need to actually say that there's 2 angles that are congruent. Okay? So I would be stating, like in terms of a proof from the statements, I would say like angle 1 is congruent to angle 2. And then over here I'd write vertical angles are congruent, okay? Now what I'm doing is I'm giving you a reason, all right? And then for this portion, I'm just going to give you a picture that would relate to it. For you guys, this is a very common picture in terms of congruent triangle proofs. All right, you'll see something that looks like this. And they'll be asking you to take this triangle and say that it's congruent to this one. And again, the whole idea of all this stuff, if you're showing that two shapes are congruent, you want to try and figure out pairs of angles and pairs of sides that are equal. On a picture like this, an easy pair to pull out would be that pair right there. Because those two angles are vertical angles. These two angles are inside the triangles, and I know vertical angles are congruent to each other. So if you see a picture that resembles this, there's absolutely no reason why you can't, like everyone should be able to take a picture, add a statement that says one's congruent to two because they're vertical angles. Even if you don't know how to do the rest of the proof, that's one step you can write down. Okay, proofs are not all or none, guys. These are explanations. Like a proof is a long explanation. So when it comes time for the test, trust me, you'll see one like this. This is just a very common figure for what goes with what we're doing now. I would expect everyone to be able to say, here's my picture. I don't even know what I'm proving, but I know one's congruent to two because they're vertical angles. So I would expect this statement to come out, and I would expect that reason to come out. And that's based solely on what it looks like. Because the way you get good at this, I'm telling you guys, is you got to be able to take a diagram and pull specific information out just based on the way it looks. Okay? The other one is going to be reflexive property. Okay? Which at the time when we did this before, right? Reflexive property, if you remember, was saying things like A equals A or B equals B. Saying something is equal to itself is what reflexive was. By itself, when we dealt with it before, it wasn't very useful. But within the realm of like congruency proofs, this thing actually ends up being very useful because this will produce a pair of sides or a pair of angles that are equal. Okay? Common pictures you would see, you might see something like this, where they got the two triangles kind of stacked back to back. Okay? And what they would be doing is probably saying, is this triangle congruent to this one? All right? Which means that if they're stacked perfectly together, this side, like AB, is part of both of them. So it counts as a pair of sides. And I know, because of this property, I know like AB is congruent to AB. Something is equal to itself. That's how it goes. And this is allowed. This would count as a pair of sides because it's part of both of the triangles. So if you ever see something that's part of both of the triangles you're working with, you're going to pull this out as a reason. And your statement is going to be, you just state which two parts are the overlapping ones. You just throw a little congruency symbol between them. Like 95% of the time, your reflexives are going to go with segments being congruent. Very rarely do you see anything with angles.
Is that the statement AB is congruent?
Yeah, this would be like the statement, yeah. Another picture would be like a diamond kind of shape, and they throw a line down the middle of it. Okay, so again, it would be saying like this triangle and that one are congruent. All right, which again, if I'm using the same letters just because I have it written over here. So this side would be reflexive, and you can even put like little congruency marks on there also, which is going to be a good thing to do. Another one you might want to add down there. Sometimes this one confuses people. But this one is like the two triangles they'd be asking about here most of the time is going to be this big triangle and the other big one. It's like someone took them and just shoved them so that they're overlapping there. Like if you separated them, they would look like this and like that. And this portion here would be this segment right there.